Okay, so I'll just make some changes. In the last equation I've made a mistake. Exponential del g by rt, it should have been a square instead of square root. So PO2 half was there. So just make that corrections in your previous slide in your notes. It will be a square because there is a square root. Now today I will move on to solving some problems from GATE previous papers. Let's see how we'll go on solving those problems. Fine. Yeah. Let's start with 2000 problem. See here in this equation is very important. You have been asked to find the free energy change from a solid copper to liquid copper, at 1300 K, right? You just note it down. You just pause the video and note it down. So you have been asked to calculate this reaction. Solid plus 0.5 O2 gas gives you Cu2s solid, and to another equation, copper liquid plus 0.5 O2 gas gives you Cu2O solid. Right? Now you have been asked, okay, just minimize this video now. Stop sharing. Now you have been asked to find the free energy change for solid copper to liquid copper. You see in these two equations, the solid copper is given in the one equation and liquid is in the second equation. So you need to combine these two equations to frame your own equation so that you can find the free energy change, right? So just looking at this equation, if you simply subtract this, let's say 1, let's say 2. If you simply subtract 1 from 2, what you will get is you will get away with this one, So you will left up with 2 copper solid gives rise to 2 copper liquid. This is a separate equation. So let's start it as delta G3. Delta G3 is nothing but delta G1 minus delta G2, right? You also need to be a bit careful about this two term because you have been asked to calculate the molar free energy change for solid to liquid copper. So you need to do away with this two term. We'll divide it by 2. So actually we'll do it in the later stage. We'll just calculate. So the idea is that you need to involve these two equations, frame your own equation so that other extraneous terms are cancelled out. So you are left up with only the terms of your interest, which is in this case a solid copper and liquid copper. It doesn't necessarily have to be a subtraction in all the cases. Okay? It doesn't necessarily need to be a subtraction operation all the time. It could be an addition depending on how you need to frame this equation. You have to rearrange the two equations or combine two equations. Maybe it can be 3 equations sometimes. So you need to do accordingly, right? Once you do this, so what you will get? You need to calculate the free energy change. So the rest of the things are given. If you just find this out, it will be 26100 minus 19.24 T. So the temperature has been given 1300 K, right? The temperature has been given, temperature at 1300 K. What is the delta G3? So it is 26100 minus 1924 multiplied by 1300. Right? If you do this, you'll get it to be 1088 Joule. Don't get surprised. We need to calculate the molar free energy. So for 1 mole of copper, we can simply do this, divide by 2, so it gives 544 Joule. This is your answer. Right? 1088 by 2, 544 Joule. So what we have done is that we have taken two equations, rearranged them, combined them to form a final equation which only involves copper solid and liquid. So for that purpose we need to do a subtraction from 1 minus 2. We did that. Get your equations like this, plug this temperature in that equation, find the free energy change. Remember that this free energy change is positive. What does it mean? That means that at a particular temperature, 1300 K, solid will not transform into liquid unless you pressurize the system. So this is not a spontaneous reaction. So you need to increase the temperature. For example, you need to increase to a temperature where spontaneity occurs, and that you can also find out from this equation. If you just find the 26100 by 1924 give you the exact temperature at which the solid copper is in equilibrium with the liquid copper, right? Okay, fine.